Hello everyone, this is Aminur Rahman and welcome to the Physics Project. Today we are going to discuss projectile motion, a classical mechanics topic crucial for all AS level physics students, whether you are from Edexcel, Cambridge, IB or any other major curriculum. Let's start. Now what is a projectile motion? To understand this, let us check a simulation first. This simulation was done using fet.colorado.edu website. Link will be provided in the description so that you yourself can check the simulation later. What you see in the simulation is a black cannonball thrown with an initial speed of 18 meters per second and with an angle of 60 degrees with the horizontal. If you observe the motion of the ball carefully, you will see that it is moving horizontally in the rightward direction, and at the same time it is moving vertically upward first and then vertically downward in the later part of the journey. This is a projectile motion. So a projectile is any object that is launched, thrown or shot into the air and then moves under the influence of gravity alone. Once it is in the air, we ignore air resistance. But why? Because including it makes the math way more complex, and at this level it's not required. That's for university level physics. Projectile motion is a two-dimensional motion, meaning it happens in both horizontal and vertical directions at the same time. Galileo Galilei was the first to realize that projectile motion can be broken into horizontal and vertical components. He literally changed the way we see motion. Think of a football being kicked by Messi or Ronaldo at an angle. It moves forward and upward, then comes back down. That's a projectile motion. Projectile motion is just two independent motions happening at once. Let us check a screenshot from the simulation again. Check the three arrows. The green one is velocity. Its direction is always along the tangent of that specific point. The black one is force acting on the object and the yellow one is acceleration. Once it is launched, there is no force sideways or in the horizontal direction, and therefore no horizontal acceleration if we consider the air resistance to be zero, because there is nothing else after the launch that applies a horizontal force on the object. That's why the horizontal motion is with constant velocity. Let's check another screenshot from the simulation with velocity components. We see that the horizontal velocity components marked at 7 different points on the pathway are the same. The green arrows are of the same length and direction, indicating the horizontal motion is with constant velocity. But there is a constant vertical force on the object, which is the weight of the object, and therefore there is a constant vertical acceleration in the downward direction. Now let's check the vertical velocity components in the diagram. We see that the vertical velocity component is maximum at A. At B and C, the vertical velocity components are decreasing due to downward acceleration or upward deceleration. At D, the vertical velocity component becomes zero. Therefore, the object cannot ascend any further. That's the maximum height position. After that, it starts accelerating downward. So we see increasing arrow lengths at E, F and G. Remember that the speed during the launch at A and the speed just before hitting the ground at G are the same. Just the direction is different, so the velocities are different. That's why we say that the vertical motion is accelerated because of gravitational force or weight. Let us check this photograph given in a question from Edexcel IAL exam board. It is question number 11, Unit 1, May-June 2015. A basketball is thrown towards a basket. The position of the ball at equal time intervals is shown in the photograph. Vertical and horizontal lines have been added to the photograph to help identify the ball's horizontal and vertical positions. What we observe is the ball's horizontal positions indicated with the vertical lines at equal time intervals are equidistant. See that the vertical lines are equidistant. This means that the horizontal velocity component is constant. That's why it is traveling equal distances at equal time. But the vertical positions of the ball are not equidistant. Check the horizontal lines. Those indicate the vertical positions. It should be very clear from the diagram that the vertical velocity components decrease with time. and therefore the ball's vertical position increases less after each equal time interval. So I guess now we have a clear understanding of what a projectile motion is. Let's summarize what we learned so far. A projectile motion is a two-dimensional motion where the horizontal and the vertical motions can be calculated independently because they are independent of each other. During the flight of a projectile, there is only one force that acts on it, and that is its weight. So only a vertically downward force acts on it, causing it to accelerate downward or decelerate upward. There is no horizontal force on it during the flight if air resistance is considered to be zero. Therefore, no horizontal acceleration, and the horizontal motion is with constant velocity. The velocity at any given point is along the tangent to the path. The vertical velocity component at the maximum height is zero, but the velocity is not zero as the horizontal component is still there and the object is moving. Now that's my time for today. We will derive the equations for projectile motion in the next video. Thank you for sticking around. See you in the next video.